All right, the recorder is on, and we are going to get the lecture started. All right, so our topic today is going to be on parameters and also returning values. So those two particular modules, which are also on Canvas, this is the parameters and this is the returning values one. So these will be the focus of today's lecture. I think I'm going to focus on returning values first. Okay, so let me reorder the modules over here and just kind of put returning values first, and then we get back to parameters because we can talk about returning values first. There we go. And here we go, going into the module that talks about how to return a value. So this one is, it can look really kind of confusing in a certain way because it has to do with how we invoke a function and how we return from a function, which we already talked about on last Wednesday. So, but this is a little bit different in the sense that when you're invoking a function, it is not by itself a statement, and instead, the invocation of a function is taking the place of a value. And what values are we talking about? It can take on the position anywhere you can expect a value, including the right-hand side of an assignment statement or inside a conditional statement. So we are going to take a look at something like this. Okay, so this one is not a good example because we haven't really talked about local variables. So instead of using this particular example, we're going to look at something that's a little bit different. And just like last time, I'm going to use online GDB to illustrate, the point of returning functions. And this is gonna be really kind of good because, we can now actually see the contrast between returning a value from a function as opposed to not returning a value in a function. All right, so let me go ahead and start to write the code here. I'm going to stick with C. Well, C++ is fine too. Either way is fine. All right, so we're going to have a function definition called f, which once again does not do a single thing. But this time we're going to have a function that returns an actual value. So in this case, I'm going to use a function g in this case to return a particular value that is an integer, and we can just go like return 14 as a value. Okay, and then we have the usual main because now that we have talked about main, every single program is going to start with main as a function because that's the entry point to how we start a program, the execution of a program. All right, since we have not talked about local variables, so we cannot really say, oh, let's go ahead and store the value of the invocation of G into a local variables. We can't do that because I haven't talked about local variables. But what I can do is to do something like this. Okay, so in addition to F and G, we have now a function called H, which is also empty, doesn't do a single thing. So this is a really useless program, but we can still use it to illustrate, really kind of important points. So we can say if, and then inside the condition of the conditional statement, we say G does not equal to or equal to 14, okay? Then we do something here, okay? This is a block statement. The only thing we're gonna do is to call function f over here. Otherwise, okay, this is the else. We call the other function, which is function h. And then after all this, we return 0, which is indicating this is the end of the main function. Um, so this is the program that we are going to trace through GDB first. And then what we'll do is we're going to go back and say, okay, on paper, how do we trace this? And what does it mean with every single line of the trace? So that's what we'll be focusing on doing today in this lecture. All right. I'm just double checking, making sure the recorder is still on, and it is. All right, so we're going to compile the program and start to debug and run it. So let me go click on debug and start the execution of the program. We'll start to put a breakpoint on line 12 first, just so that we have a chance to really look at the flow of the program. So we click start. And at this point, because the whole point of all of these demonstration is to illustrate how functions or subroutines work. So we're going to use step into all the time. Okay, we're not going to use step over or step out. We're going to use step into, which means if a line like line 12 has a function invocation, which is g open and close paren, then we are going to go into the function g to figure out what it is going to do. All right, so stepping into, and we can see that it goes straight into function g, which has a statement called the return 14. So what return 14 means is whatever the invocation was, that is causing the function to be executed, which is on line 12 here, that function invocation, which is the where the cursor is located, that whole thing is replaced by the return value, which in this case is just a constant of 14. So once we execute this, okay, you're going another step into, it is now it's closing. It is at the end of function G. So I'm not really sure whether the debugger can show us that it will go back to line 12, do the comparison, and then go to function F, but we'll see. And it does not. Okay, unfortunately, it skips a few steps. So all I can do is to show you that we end up on line 13 because the invocation of G on line 12 is replaced by the return value, which is 14 specified on line 5. So that is the reason the comparison really became 14 equals 14. In other words, we are looking for the equality between 14 as a value, which is the return value of G, versus the constant of 14 on the right-hand side. And obviously, 14 equals 14 is true. So that's why we ended up on line 13, which is another type of function call because in this case, f does not have a return value. The reason why we know f does not have a return value is because the return type of f is a void as opposed to the return type of g being an int. So this is how we can tell that f cannot possibly have a return value because the return type is a void. But function f is not very exciting, okay, because we have talked about this last Wednesday already. So we step into function f, okay, and the function f immediately gets to the end, which is on line 2, and then it goes back to line 17 because your line 13 is the last statement of the then portion of the conditional statement. And so when it is done, it will just go out of the conditional statement. And then the statement right after the conditional statement is on line 17. So when we go step into, it goes straight to line 17. And that pretty much concludes the execution of this program. All right, so let me see if there are any questions at this point before I do the actual hand trace using a spreadsheet. Are there any questions? It's easy for me to look at, whether people have questions or not because there are only two people in the class. All right. So what we'll do is now we switch back to the way that we do tracing, but inside um, a spreadsheet, because there's a special format that I use to uh, trace this in a spreadsheet. So I'm going to stop the execution. And then typically I just do the usual thing, which is copying and pasting the code. Ah, okay, I cannot hold down the mouse button consistently. Okay, let me try again. Use one hand to hold the button and the other hand to actually move the cursor around. I think that should be good. There we go. And we will open it using this program, put it up on the top right corner as usual. And then we'll go start a trace. And let me see, where's my Google Drive? I don't have my Google Drive anymore. Yep, it's still here. All right, so we'll start a new sheet for today, new Google Sheets. So if you have a computer right now, you can also follow along if you wish. 2025, today is 10/13. All right. So we are going to trace, through this program line by line. And remember, we put comments in column A now because the rest of the columns can keep moving around. So we have to put comments which is static all the way to the left hand side. And in this particular program, there's really not much to say, in the comments other than the condition of the conditional statements that we need to evaluate. Then we have line number. We have no global variables. So if we had any global variables, they would show on column C, D, and E, and so on. But since we don't, there's nothing to say here. The precondition obviously has nothing to say because we actually do not have any variables in this entire program. This entire program has no variables of any kind. So execution always starts in main. In other words, the main is our entry point of the program. So you can say line 11. Okay, that's fine. Okay, if you want to say we start on line 11, that is not a problem. Okay, even though the debugger actually does not, start execution on line 11, it starts on line 12. But that's fine. All right, so this is where the magic happens, okay? Because on line 12, we have an invocation of G inside a comparison that is the condition of the conditional statement. So from the context, it means, oh, after function G executes, it's going to come back with a return value. And then we're going to do something with that return value on line 12. So that means the return line number approach is not going to work. The return line number approach is going to say, okay, we're going to return to line 12 or line 13, but neither is right. Okay, we are not supposed to return to line 12 and start all over again because at that point when we return from function G, we are supposed to continue with the evaluation of the comparison. But at the same time, we cannot say we're going to return to line 13 or 15 because whether we return to line 13 or 15 depends on the rest of the comparison. So now we need a different way to specify, the information that we need to return. So I just use return info, as a label in this case to basically indicate return information. Okay, that's basically what it is. So the return information is also very different compared to the return line number. Because return line number just says, okay, go continue on that line when the function is done. Well, that's pretty easy, okay? But in this case, we have to go to a certain line and also indicate what else on that line we need to do. So that means the way to do this, okay, this is the format that we are going to do this, is we first indicate which line we're returning to. So in this case, in most cases, okay, the line number where we of the current point of execution and the line number that we need to return to should be the same. They go like, well, if they're the same, then what is the whole point? Well, the point is you have to actually write the entire line out, okay, with one exception. The function invocation that we are trying to address right now is going to be replaced by a question mark. So now we write this as if it is the return as if it is line 12. So let me go ahead and kind of explain what this means. Line 12, okay, this 12 colon means that we have to continue execution on line 12, okay? But the rest is basically saying when we get back, okay, the question mark should be resolved to a specific value. Then we can continue on with whatever is left on that line that we need to do. So let me just kind of pause here and make sure the rationale of why we are representing the return info is understood. We good? Good? Okay. Because the rationale is just as, if not more important than the mechanism itself. Okay, because the mechanism is, guess what? Very mechanical. Okay, a robot can do this. That's the whole point of having computers. But the rationale is the important part. Is why are we using this kind of return info to remember where we need to go back to and what else do we have to do when we get back to that line. Okay, so with that said, we continue execution at the function that we are calling. So we can see that, on line 12, we are calling G. So, we go to line 4, okay? If you don't specify line 4 in the trace and you go straight to line 15, that is perfectly okay as well. Or line 5, sorry. So on line 5, it is going to say, okay, I'm returning a value of 14. That's what line 5 is trying to say. But what does that mean? That means the entire invocation of G on line 12, okay, is supposed to be resolved to a single value of 14. Okay, so now the question is, but how do we indicate that in the trace? That's where the question mark is going to be replaced. So when we execute a statement that is that when we execute a return statement, this is what it's going to do. Okay, and you can write it down if you want to. I believe here I have it in the notes as well. We are locating the rightmost active return info column. Okay, so that's the first thing we're going to do is we are locating the rightmost active return info column. In fact, I'm just going to write it down here. Okay, so I can use comments. I believe it is Control Alt Shift M, if I remember. Nope, Alt Control M. There we go. All right. So what we're doing here is we are locating the rightmost active return info column, and then we replace the question mark with the actual return value. That is what's happening in this particular cell. So I'll put the comment here. But what we're going to do is easy. We copy the entire cell over here, and then all we do is we go to the question mark and replace it with 14. That is what we're going to do. Are we doing okay so far with both why we are doing this and also what we are doing? We good? Okay. So it is important to emphasize that when we are on line 5, we are not executing the conditional statement. All we are doing is replacing the question mark with the value that is being returned. The value being returned has to do with the expression that is on the right-hand side of the keyword return. That is all we are doing. Okay, so now what do we do? Well, there's one more thing we need to do, which is, oh, we need to kind of remember this is what we are doing. So the way I do this is I would just copy the entire line over here. This is what I do. In other words, I have to remind myself not only are we returning to line 12, but also when we get back to line 12, it looks like this now. The function G, the call to function G is already done. Is that okay? All right. But we are not quite there yet because once I perform this operation, once I copy this cell over to this cell, this column really is not needed anymore. I have just utilized the return information. So that means it's time to deallocate it. So when we deallocate, we simply copy the label and then we strike it out, which if I remember correctly, is Control Shift 5. Yep, there we go. Alt Shift, sorry, it's Alt Shift 5 is for striking out. But if you cannot remember the shortcut, you can always click on it, go to Format, go to Text, and then go to your strike out, which also tells you how to do it in a shortcut key. There we go. So now, with all that done, we are now done with the returning. So line 5 is all done. So now we are back to line 12. So when we get back to line 12, this is the first time we get to line 12. This is the second time we get to line 12 after function G is done. But this time when we get back to line 12, we go like, oh, okay, I know how to do this. We just have to compare 14 and 14. 14 equals to 14 is true. So now we actually execute the conditional statement. The first time we did not execute a conditional statement because we needed to resolve what the function call to G is going to return. That is the first time. This is the second time. So now in the comments column, we do the usual thing, which is to say 14 equals 14 is true. And as a result of this, we move on to line 13. Okay. So we kind of know what line 13 is going to do, because that's what we demonstrated on last Wednesday. But we're going to go through this anyway as a contrast of how function how the call to function f looks different from the function call to g. So from last week, okay, when we call a function, what we did was we allocate the leftmost available column, which is column C again, because column C was deallocated on row 8. So we allocate that column, and then we label the column as return line number. So this time it's just return line number because function f does not return a value to be utilized in any way. So we now remember, okay, after line 13 is done, after the function call is done on line 13, we are returning to line 17. It's not returning to line just sequential to line 13, which would be line 14, because after line 13, we are done with the then branch of the conditional statement starting on line 12, and the only statement after the conditional statement is line 17. So that is why the return line number corresponding to the call of function f is actually line 17. So I'm going to pause it again a little bit to see if there are any questions. Yes, while we are not returning to line 1, we are going to continue on line 1, but hmm, but we are writing 17 here. Oh, you mean this 13? It's a 13 because the condition of the conditional statement is true, so we just continue on to the then branch of the conditional statement. Is that okay? All right, cool. So now, after we have done this, we can now continue execution at the function that is being called, because line 13 is calling function f, so that means we continue into the definition of function f starting on line 1, and then we get to line 2 because it really doesn't do a single thing. So this is where we do the usual return, from a function that has no return value, which is something that we talked about last Wednesday. So this is basically going like, oh, okay, we are going to copy this 17 to over here. Okay, because this is how we remember where we need to go next. But after we do that, we also do not have any need for column C to hold on to the return line number anymore. So what we do is we indicate that the return line number is no longer used, and we use the Control Alt Shift 5 to strike it out. And then by the time we get back to line 17, we realize this is return 0, which means we are now done with the execution of the entire program. And then we go to post immediately to indicate this program is done. All right. Do we have any questions about how this code is traced? Because even though it is a really short program to trace, we only have with 15 rows in the trace, it is kind of complicated because we're handling two different kinds of function call. One has a return value, the other one does not. Okay, the one that has a return value is the one that is a little bit trickier to handle because we cannot just go like, oh, when we are done, we are going to go back to that line. No, we are actually changing the nature of that line when we get back. So are we okay with this trace? You okay? Okay, all right, cool. So now we're going to change the program just a little bit to see how this change is going to affect the trace. Okay, so we are going to go to, um, in fact, what I'll do is I am going to put a snapshot of this program into the trace itself as a bitmap. I think I can do that. Okay. I can't, it's not safe in the file, so it's actually easier for me to do it this way. Copy to the clipboard, and then we'll just stash it in here. So this way, you guys know what code is corresponding to the trace in the sheet. So now we're going to go to sheet 2, and we're going to make some modifications to this program. So what we're going to do is to do something that is rather simple and also, in a way kind of stupid, but it is going to illustrate, the program, in a slightly different way so that you can look at the contrast between the two traces and hopefully get a better understanding of, how that works. Okay, so this is what we're going to do. And then we just go to debug. Okay, same as usual. The breakpoint is still here, which is good. Start. There we go. So the first one, is going to be the same as last time. We go to function g, it returns a value of 14, and then this time it will go back to line 5 again. This is the second time because there are two calls to function g. So we go step into again. Now this time, because 14 plus 14 is 28, 28 equals to 14 is false. So this time we're going to continue on to line 15 like so. Function h does not really do a single thing. And then we get back to line 17 and we're all done. Okay, so GDB does not show you more details than compared to last time. So what we'll do is we are now going to look at this from the trace from using our method of tracing. And then you kind of see the differences between the first trace and the second trace. All right, so getting back to here, we're going to do the usual thing, take a snapshot of this code, okay, and then we'll go ahead and trace it. So the key idea is what if we have multiple calls of functions on the same line? How are we going to handle that? There we go. Stash it to this corner. Also make it always on top. And now we can continue with the trace. This is from last week, so I'm gonna get rid of that and then go back here. All right, so now we're back to this program, comments, line number, no variables to describe whatsoever. We are starting on line 11 again, and then we immediately go to line 12. Okay, so the key is you can only handle one call at a time. Okay, so let me repeat that. You can only handle one call at a time. So on line 12 right now, we have two function calls to G, and they are both unresolved. So that means we typically go from left to right. Okay, so in this class, we'll just kind of go like, okay, when we have two function calls to resolve, we'll just go left to right. So that means the return info column, so we allocate the return info column, and I'm going to put some comments here too. I think it's Control Shift M, Control Alt Control M. There we go. So we basically allocate the leftmost available column and label it return info. I mean, this one is not really that big of a deal because it really is about the same mechanism as the return line number, how we allocate. What is different is what do we put in this particular cell? We already know that we're going to use question marks. Okay, that part we know. The question is, which are we replacing both function g calls with question marks, or are we only replacing one of them? And then what do we do with the other one? Okay, so the idea is simple in the sense that we only handle one call at a time. It is the call that we're handling that we are replacing with a question mark. The rest of the line stays the same. Okay, it stays put. So that means this time, yep, that is correct. So this time we just go like, yep, we have to get back to line 12 when the first function call to G is done. What else is on this line? We still have the if. This is the function call, okay? The first one, the one to the left-hand side of the plus, is the one that we're handling right now. So only that one is replaced by a question mark. The other one is like, well, it's just part of the rest of the line. I don't really know what else I need to do until I get back to do it. So this is how we represent the return info the first time we get to line 12. So I'm going to pause a little bit and see if we have any questions about why we are only replacing one of them and also the mechanism of what we are doing here. Are we good so far? We good? All right. Cool. So then what do we do? Well, since we're handling a call to function G, we continue execution where the definition of G is. So we go to line 4. Now, in your trace, do you really have to indicate line 4? The answer is, no. Okay. Because if you say line 5, I know that you know where you're supposed to go. But in this trace, I'm just going to be very redundant and go like, yeah, we go to the beginning part of the entire function starting on line 4. And then we get to line 5. Line 5 has not changed from what it did before. So now we go like, okay, cool. So we copy and paste the entire return info cell and replace the question mark with the value that we are returning, which in this case is 14, like so. Okay, so what I did in cell C6 has not changed from the last time, okay? Because the motion is copy and paste the return info cell, replace the question mark with the actual return value as specified by the return statement on line 5 in this case, and that's it. That's all we do on line 5. And then we get to the actual action of returning. Okay, so now we go like, okay, so the second part of executing line 5 is to go like, well, now we not only are we specifying the return value, but we're also going to return to the caller. So that means we are going to, okay, I don't do this by hand just because there's no need to. So I copy line the entire return info to column B because this tells me what else I need to do when we get back to line 12. Without this, it would not be possible for me to easily tell what we're supposed to do on line 12. And then at that point, the return info cell is no longer needed, so it is deallocated. Okay, when that is all done, we continue execution on line um, 12 again. So this time when we get back onto line 12, we look at this and go like, well, can we get to the conditional statement and decide where to go? The answer is no, you cannot, because there's another function call. So that's why we need to redo the whole thing. Okay, basically allocate the leftmost available column, label it return info, and then we do about the same thing, except this time when we write down the return info, which is a reminder of what else do we need to do when we get back onto line 12, the first call is already resolved to a 14. So we don't touch that. We just copy that 14 straight from here. It is the second call, or the one that is on the right-hand side of the addition, that we have to replace with a single question mark, because that is the function call that we're handling this time on row 8 of the trace. So let me finish this and then I'll see if you guys have any questions. There we go. Do we have any questions? You don't? Okay. So let me handle or try to answer a question that some people might have. Some people might have the question of, well, since function g is going to return a 14 anyway, can't we replace, can't we use another question mark over here? And then when we resolve, the first question mark, we also resolve the second question mark, so it becomes 14 plus 14. The answer is no. Okay, the answer is no because the caller, which is main, has no idea of what function g is going to return. Function g, for all we know, can return a random number. So if function g returns a random number, it means the first call and the second call do not are not necessarily going to return the same number. So we cannot make that assumption. And since we cannot make that assumption, that means that we actually have to go through the motion of calling g and then calling g again. All right, so with that done, we are continuing to the definition of function g, starting on line 4, then we get to line 5, and then once again, the return statement, the execution of the return statement is going like, okay, let's copy and paste the return info cell, change the question mark to the value that we are returning on line 5, which is a 14, and we're done. Okay, we do not, at this point, we do not replace 14 plus 14 with a 28 because we are not executing line 12 at this point. All we are doing is to resolve what needs to be resolved on line 12, but we are not executing line 12. We are still executing line 5. Okay. So how can we tell? Because it looks like sometimes, the cell looks like this and we are executing, and other times it looks like this and we are not executing. What is the big deal? The big deal is if it is in column B, we are executing. If it is in any other columns, we're simply resolving the unknowns on a particular line. Is that okay? All right. All right, so line 5 is all done. So we do the usual thing, okay? We copy it to one row after, okay? We skip one row because we need that row to indicate that we are deallocating the column. So we skip one row, and then with this row, since this is a spreadsheet, I can do something like this, which is easy to do. And then after that, I have no use of column C, which is the return info. So I do the same thing as last time. Okay, so I'm just being lazy and copy and paste a cell that is already formatted with a strike through. So now we continue on to line 12. This time, when we get back to line 12, and we are using column B to indicate that, yeah, we are actually executing line 12 now. So we look at the line 12 on row 13 of the trace, and we go like, is there anything else we need to do to evaluate the condition? The answer is no. Okay, we got the left-hand side and the right-hand side of the comparison resolved. So now we perform 14 plus 14 is a 28. 28 equals to 14 is false. So we do the usual thing at this point, which is 14 plus 14 equals to 14 is false. This is when we actually execute line 12. Okay, so when we get to, well, I should be more clear. This is the only and first time that we execute the conditional statement itself, okay? All the previous times when we get back to line 12, which includes this time, they're only for resolving function calls that are on line 12 so that we can actually execute the conditional statement at this point. So at this point, it's just the usual stuff of control structure, okay? Because the condition of the conditional statement is false, and the conditional statement does have an else statement. So we get to the else branch, which is on line 15. Line 15 is also a function call, but this is a pretty simple one. So now we use return line number because the call to function h does not have a return value, so it's easier. So we set this up. The return line number is going to be line 17, and then we continue execution with function h, which is starting on line 8, and then we get to line 9. On line 9, we go like, oh, we are supposed to continue execution on line 17, so we just have to indicate that, okay, by copying 17 to column B like so, and then we just say, okay, we don't need the return line number column anymore, paste it over here, shift Alt Shift 5, strike it out. And since we get back to line 17 at this point, that means we are done with the entire program, and then we get to post. So are we good so far with this? All right, cool. All right. So sheet 2 is also a little bit complicated. Okay, it is kind of important, and I'm just trying to see if I can copy this entire image into the clipboard. Sort image data options. Yeah, it does not look like I can do it. Okay, and I can try to drag the mouse. Nope. Double click. Nope. Okay. Well, that's fine. I just have to copy and paste it directly from here. Just so that we have a bitmap of the program or an image of the program that we traced. Like so. Copy the clipboard. And then we get back to the trace. Just do a paste. All right. Oh, there we go. All right. So that pretty much is what we need to talk about in terms of returning a value from a function. Okay. So what we're going to do next is to continue to talk about parameters, but just a little bit, okay? Because parameters goes pretty deep, and we only have to get through a part of it, and then we combine that concept with return value, and then we can go back and continue with more discussion. So let's go back to here, and this time we're going to start with parameters. All right, so this is parameters. And it kind of briefly explains what is a parameter. And this one also makes use of a local variable, which we still haven't talked about. So that's fine. We don't need that for now. I can just make sample programs that do not do that. The concept of a parameter is the caller can now specify a value to be used by the callee. So that means, oh, we can actually do addition stuff. Okay, so what I'll do is I'm going to keep this add function in the sample program, and then we basically keep the same structure here. So now G is going to have parameters. So I'm going to introduce the concept of a parameter is parameter X, parameter Y in this case, and then the return value is based on the two parameters, which is the sum of those two, and then we reduce it back to one single call just to make things a little bit simpler, and then we'll give it two particular values to add, say 2 and 12, and this is our new program to trace. So it's a very related program to the first one, okay, that we did today, except this one also incorporates the concept of parameters. So the main concept, okay, the main idea why parameters are useful is it turns the function into something that's a little bit more useful. In other words, what function G is going to do is to say, hey, caller, whatever two numbers you want me to add, just put the first number into X, put the second number into Y, and I'm going to return the sum of those two particular values. So that means it is not locked in to go like, oh, I can only add 3 and 7, or I can only add 13 and 16, because now the caller gets to decide what two numbers or what two values you want G to add for you. Okay, so this is a very important concept in terms of abstraction, because this is how we can say the same function can now be used to work on different sets of data. Okay, as long as the caller knows what to add, the same function can do it. So we'll go ahead and just kind of work on this one for now, okay, and then we'll work on the slightly more complicated version later on. Okay, all right. So we'll do this, from the perspective of the debugger first. But in the debugger, nothing is going to be very fun except, well, I think we can still kind of illustrate a few useful and interesting parts before we move on. So let's go ahead and do just that. Turn it into in debug mode. The breakpoint is still at the right place, so we start like so. And obviously, we are going to continue execution on line 5, okay, because that's exactly what we did the previous two times. So we get to line 5. But one thing that's interesting about line 5 is, oh, you can now ask the debugger what is in X and what is in Y. So I can go here. Let me see if I can do that. No, it doesn't like that. Ugh. Okay. Well, the user interface is not quite as good as in a regular debugger, but I can still query and say, okay, tell me what is X at this point. It has a value of 2. Tell me what is Y. It has a value of 12. Okay, not really surprising, right? Because after all, the 2 is used to specify the X over here, and then the 12, which is our second argument, is used to specify Y over here. All right, so I'm just going to pause here, okay, to see if there are any questions about what we are observing up to this point. The function call, which is on line 12, specifies 2, which we call as the first argument, to match x, which we call the first parameter. Okay, let me say that one more time. 2, which is a specific expression, in the function call is an argument. It is the first argument. X, on the other hand, which is a placeholder of, hey, I'm the person who's going to receive the first argument or the value of first argument. The name of X is a parameter. It is the first parameter. So this is why when we check what is the value of X when we get to line 5, it goes like, oh, it is 2 because the caller says the first argument is 2. So the second argument, which is 12 on line 12 here, is passed to parameter y, which is the second parameter. And this is also why when we ask, oh, what is the value of y as a parameter? It has a value of 12. So are we doing okay so far in terms of the terms? An argument is what you specify when you are calling a function. A parameter is how you call the placeholders in the definition of a function. So the key concepts here are line 12, okay, contains a function call. This is a function call to G. And then line 4 to line 6 is the definition of the same function. Is that okay so far? All right. So unfortunately, the debugger would just go like, oh, okay, x plus y is 14, but it won't tell you that it is returning a value of 14. Instead, it would just kind of go like, oh, let's go all the way back. And then because the return value of the call to function G is also 14, 14 equals 14 is true. So we go for the then branch. And then, I mean, the execution of F is not really interesting. It's just a way for us to indicate that, yeah, we got to the then branch and then we get to line 17. The program is now done. So that is the trace inside the debugger. What we will do is we're going to go through a lot more trouble to look at what's happening in the call in this class. So what we'll do is we are going to do the usual, which is copy and paste this code, and then we'll trace it. But this time, the additional concept are parameters compared to last time. All right, so we open this up, and in the process of doing this, I might as well also copy and paste it into the image, so into the spreadsheet itself, so that we have a copy of the actual code that we traced, that we are going to trace. Okay, this is in future tense. There we go. And then this time we copy to the clipboard. Make sure this is always on top. Go to the Google Sheets, add one more, and then paste. And we can just kind of stash this all the way to the side. We don't need it because we have this. There we go. So same thing, we got comments, we got line number starting with 3, starting on line 11, then we get to line 12. Okay, so this time the actual trace looks a little bit different. In fact, I'm gonna move this one kind of a little bit more over, just because I need more columns this time. I don't want this to be in the way. There we go. Just, I mean, we get to see this already. All right, so just as last time, we have the return info. And return info is going to do pretty much the same thing as sheet 1, which is we remember we have to get back to line 12. Okay. And on line 12, we have a conditional statement. The function call itself is replaced by a single question mark to indicate, hey, this is the placeholder for the return value. Okay, so this is one way to look at the question mark, is it is a placeholder for the return value of the function that we are calling right now. And then the rest of the line is pretty much just a copy of verbatim from the original line, like so. But this time, we also have to allocate additional columns. Every parameter is going to need its own column. So this time, how many parameters do we have when we call function g? We have 2 parameters, right? So we need 1 column per parameter. Parameter x needs its own column. Parameter y also needs its own column. So you go like, oh, okay. Are we going to put question marks here because their values are unknown? Nope. We know exactly what they're supposed to be. right? Because these are parameters. So we know that we use 2 as an argument to specify the value of x. So that means the column for x starts with the value of 2, and then likewise, the column of y is going to start with a value of 12. So this is how a caller, which in this case is main, communicates with a function that is calling, which in this case is function g. Let me just pause here and see if we are okay with what I just said. Yep. So you mean the 2 and the 12? So the 2 and the 12 are determined when we perform the function call. In other words, when we perform the function call on line 12, we see that, oh, the first argument is just 2 as a constant, and so it will go to the first parameter, which is x, and that's why x and 2 are associated. And then same thing for the 12. The 12, which is our second argument, is positionally related to the second parameter, which in this case is y, and this is why the, the, the parameter y starts with the value of 12. So am I addressing the question? We good? Okay. All right. Any other questions? Nope. Okay. So this is kind of interesting because now we go like, oh, okay, so this is a new mechanism. Okay, the concept of a parameter is new to us. Okay, so that means you might want to jot down some notes about today's date, maybe even the time right now, which is about 9:47 or 52 actually, 9:52, because this is a new concept. Okay, it is a new concept. It allows us to do something where the caller can specify specific values to a callee, which in this case is function g. So the function g can go like, oh, okay, every time we refer to x, it is the value of 2. Every time we refer to y, it has a value of 12. So then we continue execution in the function definition. Once again, line 4 doesn't really do anything. We don't really have to trace it, but it's nice to say, okay, we are starting at the beginning of the definition. So now we get to line 5. So this time, line 5 is going to go like, oh, the expression of the return statement is not a constant anymore. It involves resolving what it looks like is are variables, right? It's kind of like, oh, we have to figure out what is the value of x, and we also have to figure out the value of y. But this part is important. Okay, you might want to jot it down too, or at least remember the time. When we need to resolve unknowns like this, okay, x and y, we have to look up the columns and go like, we are looking up the columns, we are locating the first active column that is labeled X, starting. Let me rephrase it because the first does not indicate ordering. I have to say we have to locate the rightmost column that is labeled X and also labeled Y. Okay. Now, the reason why I have to be this specific of saying the rightmost column that is active and labeled X and Y will be obvious later on, but right now we'll just say that, okay? So we'll go like, oh, okay, what is the rightmost column that is labeled X? Oh, that's clearly column D. And what is the value? It is 2. What is the rightmost column labeled Y? It is column E. It has a value of 12. So we add those two together. X is 2, Y is 12, 2 plus 12 is 14. So 14 becomes the return value. So that means, oh, okay, now that we know it is returning 14, then it is the same thing almost exactly like last time. It is exactly like last time. Okay, so instead of writing x plus y over here, we write down the value that x plus y evaluates to. Is that okay? So we do not write down x plus y, we write down what the expression x plus y on line 5 evaluates to because we are executing line 5 right now. Okay, we are now done here, okay? And then just like before, we now go like, oh, okay, so this is what we need to do. I'm gonna put it over here so that when we get to row 9, we know what we need to do. But then we also have to remember to deallocate columns. This time we have 3 columns to deallocate. All 3 need to be deallocated when the function is done. So they are all struck out at this point. Are we doing okay so far? So the way we allocate for the parameters is the same as when we allocate for the return info itself. When the function call is over and we are going back to where we came from, the way we deallocate the parameters is also the same as how we deallocate the return info column that is responsible to remember where are we supposed to go back to. Is that okay? All right. So now we return to execution to line 12, like here. And then we go like, well, is there anything else we need to do on line 12? The answer is no. Okay, we know exactly what we are supposed to be comparing. So now we just execute the conditional statement itself, which is saying 14 equals to 14 is true. So now we get to line 13. Line 13 is not really interesting anymore because we have done that so many times already. Okay, we go back to line 17, and then we get to line 1, then we get to line 2. Line 2 goes like, okay, we're now done. Let's go back to line 17. So we just indicate line 17 over here, and then we have to indicate the return line number column is no longer in use. We deallocate it by striking it out, striking out the label. And now we get back to line 17, which is the end of main. So that's why we get to post, and we're done. So sheet 3 as a trace looks very similar to sheet 1 in terms of what the conditional statement does. The main difference is how did we figure out the return value of 14? That part is different because in sheet 1, the way we figure out that we are returning a value of 17 is just that, oh, it's 17 as an expression on line 5. But this time we actually have to evaluate an expression, and then whatever that expression evaluates to, we return it. So are we good so far? Okay. All right. So if this is all good, let me just move this back to the main area here so you guys can see it better when you're studying. All right. So let's go take a look at what else can we do with this whole concept of returning a value. I'm looking at the time. Okay, we got about 20 minutes left, and I think we are ready for recursion. Well, let's not do recursion just yet, okay? Let's do, there are a few ways I can stack the function call versus the return value thing. Let's go ahead and do something like this. So F, G, H, I, J, yeah, we can use J. I don't like to use I because I usually is used as a variable to iterate through an array, so I don't want to use I. J is okay, K is okay. Well, let's use K. So this time go like, okay, K is returning an integer value, and it just returns a constant. Okay, so which is 5. Okay, I just picked a value of 5 here. Okay, and then this time we are going to change the ordering because in C++, you have to define a function before you can use it. So if I intend to use it in K, I kind of have to do it this way. Okay, this is what I'll do. And this time, G only needs to have one single parameter because the other value that we're adding is coming from the call to function K. And the rest of this code needs to be adjusted a little bit because when we call G, it only is expecting one single parameter. So we should only have one single argument to feed the parameter. So other than that, I think we are good to go. I think we are ready to take a look at this code. Um, I'm just taking a look at the font size here to see if I can change the font size. Let's check it out. Uh, hmm? Font size medium. Let's try small. I think that's fine because I want to be able to see the whole program when we're tracing this. The breakpoint needs to move to line 16, so I can click on an existing breakpoint to remove it, and then we go to a new line, which is line 16, and click it again. So this type of behavior is called a toggle. So when something is called a toggle, it means click it once to turn it on, click it again to turn it off. So that's called a toggle. All right, so let's go ahead and debug this program, which I think you guys already know what it is going to do. All right, so we now are on line 16, step into, it is now going to here, and then it is going to call function k, right? Function k returns back to line 5. So now we have 5 plus y. 5 plus y is 5 plus 12. So it's going to return the value of 17. So this is where the debugger just skips all the way. Oh, great. Okay, let's start the whole process again. I don't know why exactly what happened here. Okay, step into, go back. Okay, so now it is returning function G is returning 17. We get back onto line 16. Line 16 says 17 equals to 14 is false, but it won't show that. It will skip all the way to line 19 right away. That's just the behavior of a debugger. And then we go to function G. Function G has nothing to do. Go back to line 21, and we are done. So this is the behavior which is correct from the perspective of the debugger. The problem with the debugger is it doesn't show you the details that I need you to show me when you are hand tracing. Okay, so the debugger is good as a way to kind of validate your understanding, but it is not good enough to really show you all the details of what really happens when the function call happens. So we actually may not be able to get to recursion today, which is fine. Okay, it is a more mm, it's not abstract, but it is a concept that relies on a really good, thorough, and correct understanding of all the previous concepts. So we can talk about that later if we don't have enough time. That's fine. We can talk about it on Wednesday. All right, so this time I copy to the clipboard so I can paste it into the spreadsheet. So we go here, just do a paste, and then just move it all the way, all the way, all the way over here. There we go. Make sure this is always on top. Now we can start the tracing. Um, so nothing too exciting yet. Okay, and then we start on line 15 this time, get to line 16. Line 16 says, okay, I need to remember where to go back to, and that would be on line 16 again. The rest of the line is kind of boring because it is the same thing that we have done many, many times before today. And then we have to set up only one parameter this time, which is called y. It has a value of 12, okay? And that's how we set up these two columns. And then we continue execution in the function being called, which is starting on line 8 this time because we define an additional function before that. And then on line 8, it doesn't have anything to do. And then on line 9, this is where the fun begins. So we are now on line 9 the first time. Line 9 ultimately wants to go like, I want to figure out the return value and get back to the caller. That's what it wants to do eventually. But this time, the return value itself is not a constant anymore, and it is something that it cannot resolve right away because it involves the function call to k. Okay, so that means shucks, I can't really get to the sum right away. I have to call k first, and k returns a value so I can complete the summation. Is that okay? So what do? The same thing that we did when we first talked about function calls with a return value. No different compared to the first sheet, okay? Which is what? Well, we allocate the leftmost available column, which is now column E, use it for return info, and then we ask the question, does function K have any parameters? Nope. Function K has no parameters, so a single column for the return info is all we need. Okay, cool. Now we say, okay, assuming that we are calling K, what do we need to know when column K is done in terms of where it's supposed to go back to and what else is on that line? Well, we are on line 9, so that means when the function is done, it's supposed to go back to line 9. What else do we need to do on line 9? Everything else, okay, everything other than the invocation of K has not been done yet. So that means it is still a return statement. Whatever function K is returning is replacing the placeholder, which is the question mark, and we are supposed to add what? Y to it. So this is the return info. When we call function K on line 9, this is the return info. Do we have any questions about how that particular return info is determined? Okay. Do you see it is the same mechanism that we did in sheet 1? Yep, because it really is, okay? All right, so now what do? We are going to go to function K. Function K, the definition of function K starts on line 4, doesn't do a single thing on line 4. We get to line 5. So now we are executing the return statement on line 5. That one is easy, right? Whenever you execute a return statement, what do? Well, we locate the rightmost column that is labeled return info. Found it. It is column E. Good. Copy and paste its value. Okay. So we go here and copy and paste its value and replace the question mark with the value of the return expression. In this case, the return expression is a constant of 5. Yeah, that's pretty easy to do. So now we replace this question mark with just the 5. Are we doing okay so far? Has the mechanism of executing a return statement changed compared to sheet 1? Nope. It is the very same mechanism. Okay, it is the same mechanism, just applied to a different kind of scenario in this case. But it really is the same mechanism. So now what do? Oh, okay. So now that we have resolved what else we have to do on line 9, let's put it into column B just so that we remember what when we get back to that line, what else we need to do. And after that, we go like, oh, we don't need this column anymore. So copy, paste, and then strike it out. Column E is now officially deallocated. And now we continue execution on line 9. We go like, okay, can we do this now? We know what is 5 is. What 5 is? Do we know what y is? Yeah, let's go ahead and look up the value of y. Why? Okay, how do we look it up? I mean, this is obvious right now, but we still want to practice the same mechanism, okay? We are looking at all the columns, and we're trying to locate the rightmost column that is not deallocated, that is labeled Y. You go like, that's just a long and crazy way to refer to column D. Yes, okay, for now it is crazy and long and unnecessary. But the mechanism is important, okay? It is important to understand the mechanism, so later on, when things get more confusing and more complicated, we go like, oh, okay, it's the same thing that what Tex said, early on. It's the same consistent method. Okay, so that is the important part of trying to remember the mechanism itself. Look up the rightmost column that is not deallocated but labeled Y. Okay, fine. We find it is column D. Has a value of 12. So that means when we execute 5 plus Y, it is 5 plus 12, which is 17. So now we figure out the return value is 17, and now we are ready to execute the return statement itself. When we execute the return statement, what do? We locate the rightmost column that is labeled return info. Not this one because this one is deallocated. It is now this one. Is that okay? The rightmost return column, return info column that is not deallocated. So now what do? We just copy and paste it so that it's clear what we need to replace with with a value. It should only have one question mark on it. That's the one. It is 17 this time. Okay, and that's all we do. So should we just execute line 16 right now? No, we are executing the return statement, whose only job is to replace the question mark. Okay, that's all it's supposed to do. All right, so then what do? Well, now that we have resolved the line 16, we now say when we get back to line 16, this is what is left of line 16 to do. But now that I have utilized the return info cell, it is no longer needed. Okay, so we copy and paste it, but we also have to remember we also have parameter y this time. So both of those are going to be deallocated, okay, which is just copy and paste and then strike them out. And now we return our execution path to line 16. This time, when we get to line 16, we look at this and go like, can we actually execute and evaluate the conditions so that we can determine which way to go, the then branch versus the else branch? We go like, yeah, we can do this now because we know how to compare 17 and 14. So we go like 17 equals to 14 is false, okay? And because this is a conditional statement, if the condition is false, we go to the else branch, and then the else branch is on line 19. So we continue onto line 19. This part is boring at this point, okay? It should be boring at this point because on line 19, we're calling h, which means, oh, okay, function h does not return a value, so a return line number is going to be fine. And then we go like, okay, let's remember the return line number is going to be 21 now because we shifted the line numbers a little bit from last time. And then we get to the function called h, which is on line 12. It has nothing to do. On line 13, it goes like, okay, we're at the end. What are we supposed to do? Let's remember we need to continue execution on line 21 first. And then we deallocate the return line number at this point right here. What did I do? What did I do wrong? Okay, copy, paste, strike out. There we go. Now we return to line 21, which is the return zero statement of main. All done. Okay, get to post, and that's the conclusion. Are we still doing okay so far? Okay, excellent. All right. So with only 6 minutes-ish left, I don't have enough time to go through a recursive algorithm. Well, we can start to talk about it. Okay. So this way, people, so you guys in the class can kind of think about it a little bit, see if you can trace it. If you cannot trace it, it's okay. We'll talk about it on Wednesday. But I do want to give you the algorithm itself. Okay. So let's go to the algorithm here. And this time it is going to be a little bit. I don't need a whole lot of stuff like right here. Okay. I might want to keep F and H over here. And then function G is going to change a little bit. Okay, so we're going to make this a little bit interesting. So we say if y is greater than 0, then we perform a function call here, which is function G of y minus 1 plus y. Okay, I think that's cool. So when we call function G the first time, the 12 is going to be crazy. I mean, it's gonna be crazy. It's gonna go like, oh, this is a lot of steps. So we're just gonna go like, yeah, let's try 2. So it would become 2 plus 1. So we'll just compare that to a 3 over here. And this is it. Okay, this is our new code here. So you go like, well, this doesn't sound too bad. Okay, there's okay, actually I forgot about one more thing. Okay, so else, because it's a conditional statement now. The else is simple. It just returns a 0. Okay. So we'll take a look at this code on Wednesday. Okay. So what is different about this code? Well, function G got more complicated, right? That's the main difference this time. Function G got more complicated. Well, how is it more complicated? Well, it still only has one single parameter, so from that perspective, it's not too bad. But the inside is no longer just executing a single return statement. It has a conditional statement in it. The most complicated part is, oh, look at this. It is function G is calling function G again, but with a slightly modified version of the value the function G is getting from its own caller. Okay, so we will go back and talk about this on Wednesday. Okay, the main thing about this is the way we do things is not changing. Okay, the way it is calling, the way it's returning, the way we specify the value of a parameter, the val- the way that we return a particular value, none of those mechanisms are changing. Okay, the whole thing about using the rightmost column thing, now that becomes important because you will have many columns labeled return info. You will have many columns labeled Y. So the question is, which one am I supposed to use when there are so many of them? And then the other concept that is also important is you will encounter a case where you are executing a return statement that is replacing a question mark of a return statement that is in the return info cell. So you have to distinguish which one am I executing and which one is having the question mark replaced. Okay, it will look confusing, but if you understand the mechanism themselves and you just go like, okay, I'm going to execute this like a robot, you'll be fine. Okay, but if you overthink it, that's when people get into trouble. All right. So this is the code that we're going to go back to on um, Wednesday. And it would be a very good exercise if you can spend some time to see if you can figure this one out. Okay. There are two ways to figure this one out. You can run it through GDB. Okay. Let me just double check, make sure it is going to compile. Yep, it does compile. And we'll go run it and see, then make sure that it does go through. Okay. It runs through. I believe it will. Okay, yep. So it ran through because it got to here, which means g of 2 actually returned the value of 3. So everything is good about this program. Okay, the program, it will run. It is not an infinite loop. So the first thing you might want to do is really just to do step by step in GDB, and then on Wednesday, and if you can do it on paper in the spreadsheet, that's good too. It's not a homework. There's nothing to turn in. But then on Wednesday, when we come back, then I'm going to go through this in detail to show you how the trace is going to look like. All right. So thank you for showing up today. I will see you all on Wednesday. Let me stop the recorder, upload it so